What if the future of space exploration didn't depend on launching heavy oxygen tanks from Earth, but on a pipeline built right on the moon's surface, using nothing but lunar dirt and sunlight? I remember the first time I learned that flying a single kilogram of oxygen to the moon costs more than a kilogram of gold. It made me realize that if we truly want to stay, we must learn to live off the land. The headlines talk about Artemis missions and moon bases, but they miss the real revolution: a secret plan to build a self-sustaining lunar oxygen pipeline by 2029. The science is already here, and it's more real than you think. Welcome back to Tomorrow's Science. Let's dive in. Transporting oxygen from Earth to the moon currently costs around $1 million per kilogram. A single person breathes about 840 grams of oxygen daily. That math doesn't work for a permanent base. To keep astronauts alive for years, NASA would have to launch the weight of a small building every single month. This is why NASA is now betting everything on a different approach: extracting oxygen directly from the lunar surface using only solar power. Lunar regolith is not just gray dust. Almost half of its weight is pure oxygen, chemically locked inside minerals like silica, iron oxide, and aluminum. By superheating this dust to 1600 degrees Celsius, scientists can break those chemical bonds and release the trapped oxygen as gas. NASA has already done this on Earth. Their carbothermal reduction demonstration, CARD, project successfully extracted oxygen from simulated moon soil using nothing but concentrated sunlight. In April 2026, Jeff Bezos' Blue Origin announced they had successfully extracted breathable oxygen from lunar dust simulate, using a process called molten regolith electrolysis. Their Air Pioneer reactor, about the size of a small refrigerator, melts the dust and uses an electric current to separate oxygen from metals like iron and silicon. They estimate a single 1 megawatt solar array could power a system producing several tons of oxygen per year, enough for a small lunar village. If we can make oxygen on the moon, we still have to move it from extraction sites to habitats. Rovers and tanks are energy heavy and risky. The solution: a 5-kilometer pipeline called LSOP, built from locally sourced lunar aluminum, welded together by robots and designed to last a decade. This pipeline would transport gaseous oxygen at just 2 kilograms per hour, enough for NASA's initial demand. And it would use 175 times less energy than rovers. Airbus Defence and Space has designed a molten salt electrolysis technology called ROXY. It's optimized specifically for the moon's vacuum and low gravity. Their miniaturized demonstrator, weighing just over a ton, could produce more than 1 ton of pure oxygen and the same mass of metals per year. This system can even self-heat after startup and generate nearly 6 kilowatts of excess heat for other uses. It is designed to be energy positive. To build a pipeline on the moon, you need materials. The good news is that lunar regolith is rich in aluminum, iron, magnesium, and silicon. Molten regolith electrolysis can separate these metals in pure form, which can then be extruded directly into pipes or construction beams. This is the secret of true self-sufficiency. The pipeline would not only carry oxygen, it would be made of the moon by the moon, for the moon. All this tech requires continuous, reliable power. Near the lunar poles, ridges of eternal sunlight provide nearly constant solar energy. NASA is also exploring compact nuclear reactors, like the Kilopower project, to provide steady baseload energy regardless of lunar day-night cycles. With both solar and nuclear, a lunar base could power oxygen production, pipeline transport, and habitat life support without a single Earth shipment. In 2027, Interloon plans to launch a robotic demonstration mission to collect lunar regolith and prove the extraction technology at small scale. A successful demo would pave the way for the full pilot plant by 2029, a self-sustaining facility capable of producing industrial quantities of oxygen. This facility wouldn't just serve one mission. It would be the beating heart of a permanent lunar economy, fueling rockets and breathing life into settlements. When you extract oxygen from regolith, you are left with high-purity metals, iron, silicon, and aluminum, ready for immediate use. These metals can be used to build habitats, landing pads, radiation shields, and even solar panels without launching a single tool from Earth. This is what sustainability really means in space, not just surviving but thriving by turning dirt into infrastructure. Between now and 2029, NASA and its partners will test the full production chain, harvesting, extracting, processing, and distributing oxygen. If successful, the pipeline will deliver breathable air to Artemis astronauts and provide rocket fuel for missions deeper into space. This is not a dream. The technology is mature, the materials are in the ground, and the plan is funded. The moon is ready to breathe. Standing on the moon, every breath an astronaut takes could soon come from the soil beneath their boots. That changes everything. We are not just learning to visit the moon anymore. We are learning to live there, to build there, to belong there. The pipeline is the first artery of a new civilization, and it starts with a simple, powerful idea. Use what is already there. The oxygen pipeline proves that the path to the stars is not built on gold. It is built on science, engineering, and the will to stay. I want to hear from you. Do you believe that by 2029 we will be breathing moon air, or is this plan still too ambitious? Share your thoughts in the comments. Subscribe to Tomorrow's Science for more stories about the real blueprint of our future in space.